Hey folks, thanks for joining us. Today we're going to do something really fun, and we're going to take two kind of unrelated questions that we recently had in the HQ Pro, and I'm going to combine them a little bit to talk about an operator that I think is not used often enough, which is the Find DAT. And what we're going to do today is, the two questions we had first of all was, one of them is there an easy way to find all the operators that are always cooking inside of your network? The other question was, how can we take things like parent shortcuts and automatically replace them with global op shortcuts? Now, while these two things are very different, a good way to approach both of them is to actually use the Find DAT to track down all the operators that meet these criteria. So what I'm going to do today is build a quick little tool that actually takes some inspiration from Probe, which is a tool in the palette that a lot of people use for optimization. And the cool thing is that if you haven't looked inside of Probe, actually most of its functionality comes from the Find DAT, and everything else is kind of just visualization on top of that. So we're going to make a little tool here that's going to find every operator in the network that's cooking on every frame. So you could almost use this as a little mini optimization tool or as a basis for building kind of more robust systems. So the first thing I want to do is make an Find DAT. And what I'm going to do around this is just create a bunch of operators and maybe a little example network with a container and some things inside, just so that I have some operators that it can find. So for example, I'll make a constant chop here, and that's not going to cook. I'll make a container, and then maybe inside of the container, what I will do is make a constant chop. And I'll do something very common, which is maybe take something like a constant chop, plug it into a filter chop, plug that into a null chop, and then reference that value for its alpha. Now, it's not that this specific referencing of alpha is something that commonly happens, but a lot of folks always rely on filter to smooth out their data and unknowingly are causing things to always cook. So we have this constant, even though the value is not changing, what I'm going to do is plug it into an out top so I can see it in the network above. And we can already see a lot of these lines are moving, which means all of these things here are cooking. But let's say you had a really big project and you couldn't really go through every single node and wire and check, hey, is this cooking? Is this one cooking? That's not really possible when you get into bigger projects. So that's where my little tool is going to come into play here. So the first thing I'm going to do on the Find is just configure its parameters before we get into using its callbacks. So I know that I want to change its cook mode from automatic, which is right now set to, which is that every time a new node gets created, it's going to cook and find that node. And I actually want it to cook always. I want it to cook every frame and check all of the operators. Now, be careful with this, because if you do use this in your own kind of workflows, the actual Find DAT is kind of heavy because it is literally going through the whole project, every frame, and checking every operator in it for the data that we want to get. So just be mindful of that, and if you do go and use it in a project, when you're done with it, either set its active cook mode to off, or just straight up delete it when you're done. What we're also going to do is turn off the limit max depth, because we want it to go through the whole project and not just be stuck on its own network. And then what we're going to do is, we don't need to change any of the families, we don't need to change any of the filters, but in the columns, we're going to turn on path and cook times, because that's really what we want to know here. We want to know what are the cook times of the operators. And what you can already see is, because this is cooking always every frame, we're essentially getting this kind of column that's going to show all of the cook times of all the cooking operators. Now, because we're on this level of our network, and we saw that the constant isn't cooking, and only the things inside this container are cooking, we can do a nice little examination here. I'm just going to make my Find bigger, and I'm going to expose the output of this container. So I'll just put a null top here. And what we'll quickly see is, once I see its output, all of the elements inside. So for example, we had project 1, container 1 out. Here's our filter. Here's the constant top. All of those operators are now cooking because I'm seeing their output visually on the screen. But it would be too simple if we just stopped here, right? We want to do something nice, and I want to really show you some of the inner workings of the Find. So what I want to do is make a dynamic table that actually removes any of the operators that aren't cooking, because especially like if you get on a big project and there's hundreds of operators, this table is going to get real big. It's going to be hard to manage. So we essentially want the table to help us by pruning out all of the other operators that aren't cooking. So this is where we can kick back into our callback. So I'm going to hit the little purple element at the bottom right. And here we can see the callbacks. I'm going to make this a little bit smaller just so I can get access to my callbacks here. I'm going to go ahead and edit this in Sublime and bring over my Sublime window. And the first thing is we're just going to plan out what we're going to do. And this is what I do with Python a lot of the time. I don't just dive into coding. I want to make a little bit of a plan because I'm not a computer scientist by any stretch. So first, how are we going to keep track of which operators are cooking and which ones aren't? You know, your first guess, and even my first guess when I was trying this out, was what if I watch the cook times and compare them to the cook times of last frame? If there's a difference, that must mean there's a cook. The problem is a lot of these numbers are so large, you might start getting little precision errors on the rounding, and I find that to be a little bit unreliable. So what I did was I looked around at the operators and I said, okay, well, what kind of information do I get when they're cooking? So I middle-clicked on any operator, and I saw something called total cooks here. And I said, you know what? This total cook number is always going to increment every single time that operator cooks. So maybe what I can do is use that as my comparison. So every frame, I'm going to take a snapshot of the total cook value of each one of the operators, and then I'm going to compare it and see, okay, well, is the value on this frame the same as it was on the last frame? If it was, that means the operator didn't cook because the total cook number didn't increase. But if that value is different, that means it must have cooked, so I can keep track of that operator. So unfortunately, the opfind does not have a column that has total cooks in it, right? But that's not a problem because opfind allows us to add custom columns ourselves here. And we can see this is the first area of the opfind callbacks, and you can see a little comment that says, uncomment the following two functions to add custom columns. Yes, sir. Let's go ahead and get rid of the comment symbols here. And you can see it already has a template where if I was just to save this, we would see two new columns on the end, which are digits and inputs. Now, the way a lot of this stuff works, these callbacks with the opfind, is we're always returning info back to the opfind. So in this case, when we're returning these column names of digits and inputs, it's using that returned value to write those headers. And similarly, for every operator that it finds, which is going to be our cur operator, which is short for current operator, it's going to check the dot digits and put those in the first column, and it's going to check the length of the current op dot inputs and put that into the second column. Now, don't worry if this is kind of feeling a little bit strange and a little bit kind of complicated. It's really not, and we're going to work through it. So the first thing we're going to do is we know we don't need digits and inputs, so we can go ahead and delete that. What we do want is to keep track of total cooks. So I'm just going to make a new header name here called total cooks. And then I know here that I don't want digits or inputs, so I'll delete those. And I'm a big proponent of, if you don't know, check the wiki. So let's say I didn't know how to access the total cooks via Python. So I got my constant here. I'm going to click on the Python help. That's going to open up the wiki in a new browser. And I could easily just scroll through this and just read through all the pieces of information. Or I could do something like do a Control F and look for the word cook and just start kind of looking through what is available. So I got is time slice. I don't really need that. There's a passive thing, allow cooking. Starting to get closer. Cook information. I'm seeing the word cook up here a lot, so that might be good. Let's see, we got cook frame, cook time, cook abs frame, cook start time, end time. Ooh, there's the word. By the end of this, I'm going to forget how to spell cook. But we can keep going down, and then eventually we're going to see total cooks. There it is, total cooks with a capital C, camel case. If we get op.totalcooks, we'll have that exact value that we see in the middle click menu available to us in Python. So what I could do is hop back into my script here, my little callback, and say, okay, well, if my header is total cooks, then the value inside of that is going to be cur op.totalcooks. Now I can go ahead and save that. And if I zoom in, we can see now that things that have only cooked once, like this project one, constant one that we have here, that only has one cook, which we can confirm by middle clicking on constant one, and it's got total cooks 1. But then we can see these bigger numbers here, 20,000, 22,000, 17,000. These are all the operators that are cooking every frame and are just continuously accumulating this total cooks number. So far, so good. So we've started to build out the foundation of what we want to compare, but now we actually want to get into the filtering of our table. And that's where the next two functions come into play, the on find op get include and the on op found. Now we're going to work mostly inside of the on find op get include, which really the function of this one is whether or not we want to include rows in the table based on some programming or criteria. So a good example of this, and going back to what we were saying about returning a value, if we return the value of true, that operator is going to get all of its information dumped in the table. But if we return a value of false, what you'll see is the operators don't get their row added to the table. Now, when this is empty and I just have return true or return false, it's going to apply that true or false to all of them. So what we're going to do is set up some very simple conditional statements, a few if-else statements that are going to check that total cook value. But you might be asking me, well, if we're just checking the total cook value, how do we know the total cook value from last frame? Well, that's where Python storage comes into play. Because what we can do is every time we find a new operator, write its total cook value into Python storage, and then every frame that this op find is cooking, check the current operator's current frame's total cook value and compare it to what we have already inside of Python storage. So how can we do this? Well, first let's start with the simple part. Let's start with actually writing something to Python storage. So the way we can do that is very simple. We can do DAT, and DAT in this case, if we scroll up here, is the DAT that is doing the querying, which in this case is going to be our op find DAT. And I think in this example, it's perfectly fine just to use that for holding the Python storage. So we're going to do dat.store, and then all we need are a key name and the value that we want to write, separated by a comma. So we know the key name in this case, we just need something unique. So what I would suggest for that is using something like the operator path, because no two operators can have the exact same path, so that can very easily become the key name. So I can do that by grabbing our cur op, which again, like we've been using here, is the current op that is coming through the pipeline and being investigated for whether it should be included in the table or not. And that's a Python op object. So all the things .digits, .name, .path can just be used on this. So we could say current op.path, and then what do we want for its value? Remember, we want to get the total cooks. So we can do current op.total cooks. Now I can go ahead and save this, and you can see since we're returning true again, everything popped back up inside of our table. But what we can also do is actually drop in an examine DAT to take a kind of visual preview of our Python storage. So what I could do is take my op find and drag it onto the operator parameter of my examine DAT. And now we can see these are all the elements inside of our Python storage. On the left side, we have the key names, which are the paths. We have the data type that we're writing into it, which is integers, because all of the total cook value is just integers, not decimal numbers or floats. And we can see all these numbers incrementing as they should be. So now we can start building a little bit of our logics. So I'm writing this in here, and I know the first thing I said we should do is first access the storage. Let's grab the last amount of total cooks. So I'm going to make a variable called last cook, and in here what I'm going to do is fetch using the current op path to get that value of total cooks. So I can do dat.fetch, and then what I'll do is cur op.path, which gives me the key. And then what I want to do is actually write a default value, because if you think about it, as new operators pop up in the network, I'm not already going to have a total cook value for them. So if a new operator pops up in the network and this tries to fetch a key for it, it's not going to exist, it's going to error, and it's going to say all kinds of bad stuff. So what I can do is actually pass a second argument to the fetch and say, hey, if you don't find anything there, use this value instead. And this is really useful because what I can make this value is something like false. And that way, immediately after this, I can say, oh, hey, well, if you went to fetch that and your value is false, that means this is a new operator and we should store its total cooks anyways. And that's exactly what we're going to do. So the first kind of conditional that we're going to do is, and I'll make a little comment here because I like putting comments, is if this is a new operator, we have a false. So write its total cooks to the, and if you run out of space, by all means, multi-line comments are a good thing. So we're going to write its total cooks to the Python storage and allow it in the table. Great. So now that we start to write this stuff out in kind of native English, all of a sudden writing in Python is not so hard because I can say, okay, well, if this is a new operator, and how do I know it's a new operator? I know that if last cook equals false means it's a new operator because I tried to fetch its value. It had no value, therefore new operator. So if it's a new operator, I still want to write its data to my Python storage, which we have our example here. So I can just cut that, put that there. So I'm going to store its current path and total cooks, and I'm going to return true. So now what's the next step here? So we've got our condition for it's a new operator, but what about the condition for if this last cook actually has a value? And what if that value is the same as the last time? You know, if the last value is the same as the current time, excuse me. So let's do that. So let's say, okay, well, if this condition is not true, we can do an elif and say, okay, well, elif the last cook actually equals current op.totalCooks. And what this will tell me is that if the last cook count and the current cook count are the same, it didn't cook. There we go. So what do we want to do if it doesn't cook? We want to remove it from the table. So what we're going to do is return false, which is going to boot it out of our table. And then what we can do is say, okay, well, the only other condition really left is that the last cook is going to have a value for its total cooks, and the current op total cooks is not going to match, which means that it's cooked. So we want to update our storage with the new total cook value and allow that operator through into our table. Now we could go through and write a whole elif and say, okay, well, if last cook, you know, doesn't equal current op.totalCooks. But at this point, because we don't really have any other condition that we want to check for, we can just put an else and say, you know what, if it's not a new operator, and if we already checked to see if it didn't cook, everything else we're going to assume has cooked. So we can just say else, and I'll even put a comment here as good practice. Otherwise, we can assume it has cooked. And what do we say? The two things we want to do are very similar to if it's our first operator. So we're going to take the current path and the total cooks, and we're going to write it. And the nice thing is, as long as we're writing to the same key, it's just going to overwrite the same value. It's not going to create a new key, and then kind of, you're not going to have duplicates. As long as we're writing to those same unique paths, putting that total cooks number, just like we can see here in our examine dat, it's just going to keep updating the number on the same element in Python storage. So we're going to write that, and then we're going to return true. So now we can go ahead and save this and see if this is working out like we expect it to. So far it's looking good because everything in here is cooking, which is what we want. We want to only see our operators that are cooking. And let's do some simple things. Let's try and make our constant cook and see if it pops up here. So already we can see that project1/constant1, not on the list. But if I do something maybe like put abstime.frame inside of its value so that every frame it's incrementing its value, once we do that, all of a sudden /project1/constant1 is cooking, and it's now available in our table. And we can see its total cooks is still low because all of this time while everything else was cooking, it wasn't cooking. Now, why might anyone even want something like this, you can say, and once you got this set up, you can delete the examine dat. You don't really need that. That's just more for your visualization if it helps. Now, once you have this cooking, you can do some really interesting things because you can say, hey, well, I'm seeing a lot of things inside of container1 cook, but my output is not changing. So then it starts to help lead you down the pathway of saying, okay, well, maybe let me go look in there and I can take a look around, and you can say, okay, well, you know what? My value's not changing, the filter's not changing, but the filter is still always cooking. And that'll start to build this habit of noticing which operators are always cooking and which ones aren't. You know, some filter chops, logic chops, count chops. There are quite a number of chops, even especially the inputs and outputs like OSC inputs, that even if their values aren't specifically changing because of how they're programmed, they're always going to be cooking. And especially for new users, it can be really hard to find out which operators are cooking and aren't cooking. And I think using something like this is a really helpful tool for anyone, whether you're beginner, intermediate, or advanced. As you're starting to get into optimization, this can be a really helpful tool. Now, aside from this specific application, this should start to get you a little bit more comfortable with the inner workings of the op find, and how you can add custom data to that table, and how inside of the op find op get include function, that's a bit of a tongue twister, inside of that on find op get include, you can do things like conditionals, check for certain things, and even like at the beginning I mentioned, where if you wanted to do something like look for parent references inside of parameters, you could do that in here. You could say, okay, well, get the parameters of each current op, look through them, see if the word parent with brackets appears. If so, do this. And this can just help you really get a good feel about what's going on inside your network at large without you having to physically dive in and look at every single operator. So I hope this is helpful. Op find is something I use all the time. A lot of pros use this in so many different ways. And as you saw, we can make optimization tools, you can make helpful scripting tools, and more. Enjoy. Hey folks, thanks for watching. If you're serious about learning TouchDesigner and getting into our interactive and immersive industry, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner interactive professionals. You can click the link in the description to learn more about that. And if you liked this video, hit that like button. And if you're new here, don't forget to hit subscribe and click on the little bell icon for more awesome free content.